So now let's try and do a few exercises to help reinforce all the concepts that we've learned so far. This is so that instead of just following along, now this is your opportunity to try and utilize what we've learned to try and accomplish something, and then I will walk you through how to do it. So this is now where you can apply the concepts in a slightly different way. I'm going to ask you try and toggle a game object, the active state, which is going to be this up at the top, this whether it's active or not. Just create a cube and make this turn on and off on the Q key press. So try and accomplish this so that you can create a script and press the Q button and the cube will turn on and off. So go ahead and try to do this, and then I will show you my solution after give it a shot. So just pause the video here, make your attempt, and then I will continue and I will walk you through the answer. Make sure that you actually give it an attempt though. So let's think through this. What do I need to accomplish this challenge? Well, first of all, I need a cube in order to turn something on and off. So I'll just go ahead and make that, save it. And then I also need another object that can affect the cube. Now, technically, you could put the input detection on the cube, but keep in mind, if you were to do that and you turned your cube off, your script that's detecting input would no longer run because it's on the cube. So to me, what makes the most sense is to make a level controller object and then reference the cube and then turn that cube off remotely and do all the checking like on and off. So I'm going to create empty and I'm going to create a level controller. Call this object manipulator or something. Doesn't matter. I'm going to make a new script, create C# and call this level controller. I'm going to put this script on the level controller object. Okay. And now on my level controller object, if I double click and you let that open up, think about what you need. I need to know which cube to turn on and off, or which game object to turn on and off. So I'm going to expose that to the inspector and say, I don't know which one to manipulate yet. So game object, just call that object. I don't know which object to manipulate yet, but I'll let the designer decide that in the inspector. So I'm just going to leave my reference open like that. And then inside of update, let me get rid of the comment. I'll say if any frame I detect the input.getKeyDown key code.q. If I detect the Q button press, then I want to toggle the cube. Now I'm going to actually leave this as a separate method just to remind you that you should be grouping things into custom methods if it makes sense. So I'm going to create cube, make sure it's the same name. We're just going to jump down here. If we press Q, everything related to toggle cube will go inside this method. Now, at this point, you could put a large block of logic, and that could be fine, but I want to show you how I'm going to solve this, and I'm going to try and make this as readable as I can. First thing we need to know is what's the current state of the cube so that we can reverse it. So I'm going to create a local variable of type Boolean, and I'm going to say current state is equal to, and then I'm going to get access to my object up here. So my object inside of game object, if you look in the Unity API, you'll see one of the things that we have access to is the object's current active state. Another way to find this is if I just type dot, I can see everything related to the game object in here. And one of the first things I see is active self. And that's going to tell me whether or not this game object is currently active. And this is what I want. I'm going to create a new local Boolean that's going to store the current either true or false of my object, like whether it's currently active or not. So we'll say active self. So I'm taking whatever this is, true or false, whether or not it's currently active, and I'm storing it into a Boolean. And then I'm going to actually perform the action. I'll say object dot set active. I need to decide whether I want to turn this on or off. What I want to do is just assign it to the current state and then use the not, which is going to be the exclamation mark. That means the opposite of whatever this is. Now, one thing I could do is I could have just put this entire thing right here, and this would still work, something like that. But I wanted to show you that you can use local variables to make this more readable. If I handle one problem at a time, and I figure out what the current state is, or the current active state, and then I figure this out, and then I go and I perform the function with this, it becomes more readable because I'm only tackling one thing at a time rather than trying to figure out this and put it inside of here and then reverse it and then do this other thing. So I recommend that when possible, use local variables to make things more readable. And this is just one way of doing that, just to show you an example. So I'm going to save this. Now we can look at our code pretty clean. If we press the Q button, run our method, and our method toggle cube tells us what it's going to do, get the current state, and then reverse it, and then call the method on the object. Save it. Make sure that we have assigned our cube and the level controller, right? Then hit play. Now, if you click down in the game view and you press Q, your object should toggle on and off, just like that. Just cool. This is my personal solution to the challenge. If you made it work, then that's great. That's all you needed to know. There is no correct way to do the majority of these things in the examples. You may have found a different solution. You may have put all of this inside of here. You may have not done this. That doesn't make it wrong. It's just a different way of doing it. And a lot of coding is finding a balance between optimization and readability and many other things. And that's why you're going to have different solutions for different things. So the important thing is that you understand why we're writing things this way so that you can do what makes sense in your own solutions.